right, this is the catalyst for January 14th. We had two questions. One was about enthalpy and entropy. The other was about dilutions. So let's start with the first one, which is about entropy and enthalpy. All right, so it says, which of the following reactions is most likely to have both a positive delta H and delta S? All right, so if we see positive, then we immediately need to think about what that means. So positive delta H means that the reaction is endothermic, meaning that I have to put energy in or heat in. So heat can't be a product. That automatically takes out B and B. So now I'm left between A and C. Now, positive delta S means that my disorder is increasing. So that means I'm going from a very ordered, structured system, like a solid or a liquid, to a very chaotic system that can move anywhere it wants to go, like a gas. So states of matter is really your friend when you're looking for a positive delta S. So here I see a solid going to two gases. Here I see two gases going to two gases. So the entropy here, the amount of disorder, the amount of degrees of freedom that C has, is relatively staying roughly the same. But if we look at A, we're clearly going to a more chaotic system. So A is our answer there. All right, for the second one, we're actually looking for to see how do we make a solution. So this goes back to what we were talking about early in the first semester. So here it looks like we have an 18 molar sulfuric acid solution. We want to make 1 liter of the same solution but at 3 molar. So it looks like we're going from a very high concentration to a very low concentration. Well, not a very low concentration, but a low concentration. So this is a dilution question. And the minute you figure out that it's dilution, the first thing you should do is go to the equation M1V1 equals M2V2. And so that's what we're going to do. We're going to write M1V1 equals M2V2. I'm going to go ahead and label what everything is. Since 18.0 molar is your higher concentration, this must be your M1. Since I want to make the proper procedure to create, saying to create, then that means that this is what I'm going to end with, so that's my V2. This is my M2, because that's what I want to create. And so it looks like it needs to know how much V1 is needed to make that solution. And then it doesn't just want you to calculate. No. It says it needs the procedure. So let's first tackle the calculation and then we'll tackle the procedure. So we're going to divide by N1 on both sides to isolate that V1. And we get V1 is equal to M2 times V2 over N1. So that means that I'm going to take 18 molar and I'm going to multiply by, just kidding. Sometimes we make mistakes and that's okay. We're going to take 3 molar because that's my M2, and then we're going to multiply by 1 liter because that's my V2, and I'm going to divide by 18 because that's my M2. So when I do that, I basically get 1/6, which is 0.167, and that's taking away the concentration units, liters. Always pay attention to your liters, or to your units. Don't just assume, because you know what assuming is. All right, so that's not what the question asked. The question asked for the procedure. So you got to remember that when you make a solution, you make it in a volumetric flask. If you need a 1 liter solution, then your flask needs to be calibrated for 1 liter. You're going to add 0.167 liters to a 1 liter flask, volumetric flask. And dilute with deionized water to the mark. So we're going to add that in, and then we dilute with water to that mark. Okay? That's how we do that. Perfect.